Right. So I start with the software engineering. Yeah.
Yeah.
Okay. So software engineering has two indicative contents, learning outcomes. Understand the software engineering approach to design and development of the software, and second is understand key aspects of software engineering. So, and the third one is be able to apply the software engineering approach to software and system development. So basically what I believe is this task should have been in the first number, like key aspects of software engineering, and this one should have been second one, but no worries. Before we start with the software engineering, I would recommend to go through the software engineering book. The book is basically the Software Engineering by Ian Somerville. This is a kind of, you can say it's a textbook for the software engineering, and in the software engineering you would find certain key important chapters or sections, like part 1 is Introduction to Software Engineering, Introduction, Software Process, Agile Software Development, Dependability, Security, Advanced Software Engineering, Software Management, and these things. So before you start the software engineering unit, you should have a look on the software engineering book, or one of your friends for the software engineering unit should be the software engineering book by Ian Somerville. So the software engineering itself is basically the related with the system and software engineering. It is not only restricted with the software engineering, like related with the software, but it is also related with the system development. And obviously the system is composed of certain hardware as well as software. So theoretically you should learn that how and what the software engineering is and its approaches, and how it is used to design and develop the software. So we start with this software engineering unit, learning outcome 1, understanding the software engineering approach to design and develop the software. So let me put the okay, so there are about 32 slides. I will try to finish within this session for the learning outcome 1. So what are the principles of the software engineering? What does it take to ensure a successful software project? If the successful software project it is now appears that there are at least 7 basic principles for that, right?
Right.
What are those principles? Manage using a phased life cycle plan. Whatever the development you are doing, it should have a phase-wise cycle. Then perform a continuous validation. Validation is to check whether the appropriate results are being achieved or not. Maintain a disciplined product control. A disciplined product control is when you have produced a product, then whether it has a quality of the product overall from the first day of use to the maybe after 6 months, whether it is maintained or not. And then use a modern programming practices, maintain a clear accountability for results. Whatever the results you are receiving through the software, whether they are accountable. You can justify that the results are correct or not, use better, and fewer people maintain a commitment to improve the process. So let us discuss each principle one by one. Manage using a phased life cycle plan. Importance of the project life cycle plan is roughly 50% of the projects fail because of poor planning. So planning is basically based on that you should get the requirements, you should design the software after getting the requirements, then you implement it, and then you test it and you maintain it. If you do not follow a proper life cycle, then roughly 50% of the projects fail because of the poor planning. Essentials of a software project plan, they include project overview, a summary of project, read by anyone, and phase milestone plan is description of products to be developed in each phase. So you should have a review of the project overall, and you should have a phased milestone plan so that each phase should be developed according to its description. So it shouldn't go out of the description that what is going to be developed according to the plan. Then project control plan indicates that the project organization and associated responsibilities should be identified. So organization, how the project is organized, and associated responsibility should be identified. If you do not identify the associated responsible persons, whatever the resources the organization is, you will fail. Product control plan. The product control plan is identify the major activities involved in software product or control, configure, and identification. So as I explained earlier, whenever you develop a software, you hand over the software, you should hand over the software in a form of product. And the product is basically configured, used in an identification form, so that every kind of configuration, whatever the product has been made according to the specification, it should be involved and identify the activities whichever comes with the product. Then next is the validation plan. Covers much more than the usual plan, and you need to verify that what the expected output of the software is and whether it is validating the software or not. Basically these terms like validation, control, and verification, these terms have a clear meaning in the software engineering terminology, like quality of service, functional requirement, non-functional requirement, like a verification, validation. They have a very simple meanings. Once you will learn those meanings, then you can directly hit the terminology and idea behind. When it comes to the verification and validation, then you are talking about the performance of the software in terms of functional requirements or non-functional requirements. So after reading this whole book, whole unit, once you will memorize these definitions, then you will be comfortable. So at the moment, I am just giving you the kind of generic definition so that you can understand. Then operations and maintenance plans include an overview of the concept of operation for the system and plans for training, installation, and data entry. So overall, the managed phase plan has to be carried out as a basic principle of the good software. Number 2, we come to the perform a continuous validation. There is a single message about developing a reliable software which outweighs all the others, it is to get the errors out early. So in the validation, as I explained earlier, that whether do you get the correct results or not. If you are getting the results wrong, then it means you are getting wrong results. So that's about the errors. As soon as you get the errors identified, it means you have validated the software and it has performed the validation. Now, the validation will give you the errors, the errors identified, and verification will let you know the performance of the software, that performance whether it is reliable or not. So, getting errors out early, the first step is to incorporate early validation activities into the life cycle plan. Each early validation subphase implies two things: the validation activity itself and plan preceding it. So overall, validation is identifying the errors and testing the software from every aspect. Maybe it is the whole or maybe is the individual components to be tested. Furthermore, specific activities which aid in eliminating the errors in the requirements and design phase include in-depth review, early user documentation, prototyping, and simulation. So obviously the in-depth review will give you an insight of the software components to be reviewed. Early user documentation will help you to identify that what important things have to be implemented and its correct order and and the sequential implementation will help you to get it validated. Prototyping would also be better to give you a way of using the software for its validation, and simulation is kind of the simulated and imaginary use of software. Like particularly on larger or real software systems, simulations are important in validating their performance requirements or throughput, response time, spare, storage capacity. So you can validate your software by reviewing the in-depth components based on the documentation, providing a prototype, or simulating the software. Simulation is a kind of demonstration or the process of execution using an automated systems or softwares in order to validate the system accordingly. So these steps will help you to get the validation done. Next is maintain disciplined product control, baseline configuration management. The most effective system of software product control is the baseline configuration. A baseline is a document or program which undergoes a formal validation or approval process and thereafter may only be modified for formal procedures established by the project. After undergoing a preliminary design review, the document is baseline and enters into a formal configuration management. So, baseline, if the baseline configuration is maintained, then you are basically controlling the product. You are controlling the discipline of the product. If the every configuration is predefined and validated for the approval of the final product. The process of product control consists of four basic functions: configuration identification, configuration control, configuration status accounting, verification. So, for example, the configuration identification is configuration of a computer program is identified and documented in a series of specifications. Configuration control changes to the established specification of computer program to the program itself are classified, evaluated, approved or disapproved. So, if you want to produce a product, a disciplined product control, then you have to consider the configuration the control of configuration, the status accounting, verification, and these things. We come to the fourth principle is use modern programming practices. The use of modern programming practices, MPP, including top-down structured programming and other practices such as information hiding, helps to get a good deal more visibility into software development process. Basically, the use of a modern programming practice is basically, if you consider about the old programming practices, then you would start probably with the very old programs like assembly language, the basic Fortran, COBOL, earlier languages. In those languages, there used to be the lines of code into a sequence. Like, let me show you the example which can really help you to understand this. Now, if you look at this, let me get the better example. Yes. Now, this is a kind of an early programming language, a system programming. What you need to do is write this program line by line, and for just writing one program, like saying hello world, you need to write about 10-15 lines, and if whenever you wanted to add a kind of two numbers, then still you need to add and use like maybe 50 lines of code. So then you got a procedural programming. Then the high level programming languages, they gave you an option to write down the programs into human friendly languages. The generation of the languages started from like a machine language or assembly language, and then it came to an existence of the modular programming languages, where they tried to write the code into modules or functions, and then after the modular programming, certain new ideas came into the existence, like an object-oriented programming. Then object-oriented programming provided you the information hiding. They provided much more manageability into the programming. Like the core pillars of the object-oriented programming is inheritance, encapsulation, polymorphism. So these kinds of more real life oriented programming languages, which provided more features, they created the more easiness into the programming. So the more you will be using the modern programming languages, you will have and you will get a good deal more visibility into the software development process, which contributes greatly to getting errors out early, produce much more understandable and maintainable code, and makes many other software jobs easier, like integration and testing. However, MPP, modern programming practices, are by no means a substitute for the other basic principles, and some projects have proven. So, just wondering, programming language?
Sorry?
Have you done any programming language?
I done Java and VB, Visual Basic.
Have you done the Java?
Well, Java was a bit hard compared to Visual Basic, but I have a basic, very basic idea.
Is it? So where did you do the Java?
Sorry?
Where did you learn the Java, and which course?
I had another course previous this one.
In which course, like?
It was about programming mostly.
Okay.
I have an idea. I have programming methods, which is basic Java.
I mean, where did you learn this?
Oh, in Malta. There was a school.
In a school, okay. So that's all about, the programming, and the Java is one kind of modern language that you need to use. So it's why we are talking about the software development, and the software development, the good software development technique is encouraging you to use the modern language. Yeah, that's the point that we are discussing here. Yeah.
Yeah.
Okay, so once we will programming language itself, then there is obviously a good, the discussion behind its features, benefits, and disadvantages. Yeah. Now, the modern programming practices implementation guidelines are ensure that the management is committed to the modern programming practices. So this is all about the modern programming practices. You need to ensure that you are using the modern languages instead of the old languages, so that the manageability of the software development should have an advantage of using those approaches. Now, maintain a clear accountability of the results. Each individual on the project team should have a clear statement of the results for which he or she or his groups are accountable, and clear understanding that his or her future rewards depends on how well he or she does in producing those results. So if you want the accountability of the result, like whatever the components of the softwares are developed individually or in a group, they are basically responsible for the correct results. If you look into the accountability for their own or as a group, you should consider its accountability. For a project to be able to do this, one additional thing is needed, which is the adequate visibility into each person's group or project performance. Whatever the activity is being carried out, it should be very much clear that who is doing and what they are implementing the parts of the project, and there should not be any unclarity that who was responsible for that particular segment of the project. The visibility is particularly difficult to achieve on a software project with their lack of tangible products, because the products change over the time, the phases change over the time. It is little bit difficult, but to get this visibility, it is necessary to break the software process into a large number of well-defined steps, and to organize the project around these steps in such a way that each individual can tell whether they are doing their job well or not. So overall, the accountability of the results is depending on the number of people who are developing the software in individually or in groups. So they should be made responsible for the individual segments to be developed. The use better and fewer people. One main motivation for a Principle 6 it's a kind of software development is the wide range of variability among the individuals with respect to their software productivity. Another main motivation for Principle 6 is that reducing the communication overhead on a project by getting the job done with fewer, more productive and performers. So basically, if you are involving more people and they are not expert at all, they can mess up the discussions, communications. However, if you reduce the number of people and replace the more number of people with fewer people with highly technical knowledges, it is much more wise thing, much more beneficial to produce a good software. Maintain a commitment to improve the process. You should be very much committed. Like principle 6 are not quite enough to principle 6, 1 to 6 is basically the using fewer people. So apart from principle 6, in maintainability, the principle 6 is basically we are referring these 5, 6 principles, like 1, manage using phased life cycle, perform continuous validation, maintain disciplined product control, modern these things. So up to here, until the principle 6, the people should have been quality, not the quantity, and the number 7 says in order to maintain a commitment to improve the process, the principle 1 to 6 are not quite enough to guarantee a healthy software engineering organization. Right? There are enough to get an organization to do good in 1982 vintage software engineering, but not enough to ensure that the organization keeps up with the times. Furthermore, there is no need to be a way to verify that the particular form of principles and adopted by an organization is indeed the best match for its particular need. So this motivation for the principle 7, maintain a commitment to to improve the process. Do you understand? Did you get it?
Sorry?
Did you get it? Like it says
Yeah.
that for a good software, the basic principle should be these 1 to 7, but it says that until 6, if you have followed everything, but that's not sufficient. At the stage of number 7, maintain a commitment to improve the process. You should not only focus the vintage software technologies like the modern, the old methodologies of the software development, like a waterfall and the basic software development methodologies. You should be keenly interested to incorporate the new things as well. Right?
Right.
Yeah. So that's about the software engineering principles in order to provide a best and successful software project. Yeah.
Yeah.
Now we come to the system development process. So the system development process itself is a conceptual model used in project management, describes the stages involved in the information system development project from initial feasibility study through maintenance of the completed application. So normally there are 6 phases in every system development process: requirement gathering, then designing, implementing or coding, testing, deployment, maintenance. Let us look at these steps in general. The existing system is evaluated, deficiencies are identified, new system requirements are defined, the proposed system is designed, system is developed, system is put into the use. Once the new system is up and running, it should be evaluated and maintained. So like this: analyzed, designed, implemented, tested, developed and maintained. So these are the definitions about these phases. And now we talk about the software development management. Software development management is a complex process that not always can be universally managed through issue tracking or project management software. Very important point, that software development management is very complex process that not always can be usually managed through issue tracking or project management software. So the reason is that the development is based on the coding, and you cannot trace, identify the progress, that how the progress is going on, no matter if it is error free. For example, if you ask few of the programmers to write down the code, and if the programmers were writing like hundreds of the lines of the code, and finally you came up with the wrong code and the wrong logic, and possibly if one programmer did a few lines of code, those lines of code were really fine and they didn't have any error, logical or syntax errors, then obviously they were fine at that time. So the process itself cannot be traced or tracked. Usually there is a significant amount of the work that requires handling through configurable workflows to enable optimized tasks, handovers, task transitions, approvals, and task completion. So that's about the software development management. Processes that are in the software development management is trouble ticketing and bug tracking. So in the software development management, probably you must have seen trouble or ticketing and bug tracking, forums are there. If you wanted to report any bug for the software, then the software development team asks you to create a ticket, or then your bug will be tracked. Change management and the change request. Possibly you required a change into the software develop, incident and problem management, and the SLA management. Now, little definition about the errors and the bugs is basically, normally if you have developed any software, then possibly you will be facing many errors. Once you remove the errors, then possibly still you will have some bugs. Bugs are kind of the errors which may be the logical errors. The software at that time was implemented fine, it was tested, but at the later stage, the certain use of the software produced an error, maybe the logical error. The logical error is kind of error which does not give you the right answer. However, the syntax error would give you an error, a malfunction in the software program that will stop you from running the program. So obviously there are certain errors like syntax error, logical error, and semantic error. So logical errors would give you the wrong results, and the semantic errors probably would give you a wrong meaning of the output. So this is a little bit further discussion topics, but overall the software development process involved a ticketing, a change management request to be entertained whenever there is a need of change. Then the request should be entertained. Any incident or problem management should be done. SLA management. SLA management is the service level agreement management. Whenever there are certain terms and conditions of the software defined before the use of the software, before the purchase of the software, then service level agreements, the terms and conditions should have been maintained. So these are most important in the software development management. So traditional software development approaches, the several software development approaches have been used since the origin of the information technology. The traditional methodologies such as waterfall that have distinct phases are sometimes known as software development lifecycle methodology. So traditional are the SLDs, though this term could be used more generally to refer the methodology. A lifecycle approach with distinct phases is in contrast to agile approaches which define a process of iteration, but where design, construction, and deployment of different pieces can occur simultaneously. So basically, you have to go through the system development life cycle and certain phases, and obviously how you proceed with those steps. Possibly you could go through with the normal or conventional methodology, which is normally the waterfall model, or probably you could go with the agile approach. Agile approach is basically the approach of the software development, allowing the steps from requirements, design, implementation, coding, and these things, but in the form of iterations. When you follow the iterations, it means you are going through the process of development into iterations instead of going through as a whole. So these are the approaches. We discuss little bit more in the waterfall development is the requirement analysis, software design, implementation, testing, integration, development is basically done into steadily downwards like a waterfall through several phases. You are not allowed to go through once the requirement analysis is done and then you are again doing the, for example, after the requirement analysis, you did a software design and then you did an implementation, and then you are not allowed to do the analysis again at any stage. But every stage has to be completed and move forward accordingly, otherwise the approach will not be considered as a waterfall approach. Then prototyping. Prototyping is about creating prototypes, an incomplete version of the software program being developed. And obviously prototyping has certain advantages and disadvantages, and the basic principles of the prototyping is not a standalone complete development methodology, but rather an approach to try out particular features. So when you provide a prototype, you are basically providing a kind of semi-complete software. This is a kind of approach in order to attract someone very quickly and to move forward accordingly. Incremental development. The various methods are acceptable for combining linear and iterative system development methodologies, with the primary objective of each being to reduce inherent project risk by breaking a project into smaller segments and providing a more ease of change during the development process. These are three main variants of incremental development. A series of mini waterfalls are performed where all phases of waterfall are completed for a small part of a system before proceeding to the next increment. The second one, overall requirements are defined before proceeding to evolutionary mini waterfall development. The initial software concept, requirement analysis, and design of architecture and system core are defined in a waterfall. So the prototyping is producing an incomplete software. The waterfall allows you to go through step by step, but once every step is complete, while in the incremental one, you keep on going with a mini waterfalls. It means you did a 10% requirement analysis, you did a 10% design, you did 10% implementation, you did 10% testing, and then you can move and restart from the requirement analysis for another 10%, and then another 10% design, another 10% implementation. So waterfall, prototyping, incremental, they are a kind of the methodologies, traditional approaches that you select for the software development. And obviously there are lots of programming in the approaches that are used by the different software developers, and you follow those accordingly. So I have to, the next is, what are software process modeling? A process model describes a sequence of phases for entire lifetime of a product. Therefore, sometimes it's also called the product life cycle. This covers everything from initial commercial idea until the final deinstallation or deassembling of the product after its use. The waterfall model that we discussed, and V model is also a kind of software model when you do the every validation in parallel. Spiral model is also kind of the software development. At every stage you look at the risk of every phase, whether you should go ahead with the next phase or not, and Consequently, the Agile is a model that believes that every project needs to be handled differently and the existing methods need to be tailored to best suit the project requirements. In Agile, the tasks are divided into time boxes to deliver the specific features of a release. Iterative approach is taken and working software build is delivered after each iteration. So Agile is basically the kind of iterative approach and done into the incremental phases according to the time. Whatever the time you have, you come up with the increments. However, in the normal waterfall model, you need to go through each and every phase. Once every phase is complete, and then you can move forward to the next. However, the waterfall model is the oldest model. Then the new approaches like a prototyping, the iterative, the agile things are the current versions of the methodology that you really need to adopt those. Like in the previous slide, the good principles of the software, the number 7 was to not only focus on the vintage software developments, like waterfall was the vintage software development, but adopt further more software development processes. So these are the like incremental, the agile, or basically the new modern methodologies. So tools for the modeling tools. The next topic is modeling. Software modeling is basically representing the structure, the diagrams of your system model. How? When it comes to do the modeling of what the system actually wants to develop, its modeling is important. Without modeling system structure, the exact outcome cannot be received. So Rational Rose, Microsoft Visio, Star UML, online Google Draw tool, these tools help you to draw your pictures of the system, of your design, of your architecture, software architecture. Probably you must remember that in the system analysis and design unit, there was I discussed about the UML, and the UML is a kind of unified modeling language in order to show the designs of the system using use cases, class diagrams, association diagrams, and all these kind of artifacts in order to show the software modeling. You need to have a tool particular. Do you remember we discussed the UML last time? Yeah. So that's about the modeling. We discussed the modeling, the agile software development, how it is, and process modeling itself. Then we discussed little bit more about the traditional approaches which are used, and we discussed about the management, how you need to manage the software development, and process itself is the system development life cycle. We discussed about the basic principles of the software that needs to be considered. So it's the learning outcome 1 is complete now. And do you have any question now?
No questions.
Okay, that's fine. So we take a 5-minute break, and then we start the next session, after the break. Yeah.
All right. See you in 5 minutes.
Yeah, about 5 minutes. Yeah.
Thank you.
All right. Okay. See you in a bit.